Hello and welcome to this video about diagonalizing matrices. The main reason that matrices are diagonalized is so as to perform functions on them, like exponentials, sine, cosine and square roots, and various other types of these special functions, since it is the best method to do this. In this video we'll learn how to program a computer to find the characteristic polynomial for you, which is the first step in diagonalizing a matrix. So the first step in this process is to find the characteristic polynomial of a matrix, which is well described by the following equation. The characteristic polynomial of a matrix is equal to the determinant of this matrix with a variable usually called lambda subtracted from the diagonal elements. Lambda is equal to the eigenvalues of the matrix when the determinant is equal to 0. So this is how a human would calculate the characteristic polynomial, by firstly calculating the determinant of this matrix and then simplifying it to give this polynomial as shown below. A computer would find doing this extremely difficult, because it doesn't like to work with algebra directly. So this is how a computer would do it. It would substitute different values in for lambda, say lambda is equal to 0, 1, 2, 3, etc., and evaluate the corresponding determinants. Firstly, we'll find the determinant of this matrix corresponding to lambda is equal to 0. So we'll substitute this into the expression as shown, and we get this expression, which is equal to the determinant of the matrix with nothing done to it. And the computer can easily find the determinant of a matrix quickly using the function to find its reduced row echelon form. And so we can use the same method to find the determinant for lambda is equal to 1, and then find the determinant for lambda is equal to 2. And because there are 4 coefficients in the characteristic polynomial, we'll have to find the determinant of this matrix for a 4th value of lambda, namely lambda is equal to 3. So now we have 4 points on the line to find the characteristic polynomial, which can be found exactly, because we need 4 points to find it. We need to find the polynomial's coefficients, which we'll call b0, b1, b2 and b3. So we'll create a polynomial interpolation matrix so as to find it, and this is what it looks like. You should be able to see why this equation solves for the coefficients of the characteristic polynomial. Just try to expand it out if you have trouble seeing it. And this is what the interpolation matrix looks like when it has been evaluated. And solving it gives us these values for b0 to b3. And so the computer has easily found the characteristic polynomial. It could have just as easily found it for a 100 by 100 matrix. But for the sake of reducing numerical error, values for lambda, like lambda is equal to 1.1 and 1.2, might need to be used, so that the numbers in the interpolation matrix don't grow too large. The eigenvalues of this matrix are the roots of this polynomial, and we'll discuss how to get these values in the next video.